All right. Yeah, I'm Andrea, work for NVIDIA. So in this talk, I would like to do a quick recap and overview of what's the progress of SCADX. You guys should be all familiar with what SCADX is, because I see at least one SCADX person in literally each table. So yeah, I'll go fast with the first phase. So yes, SCADX is a way to replace the in-kernel scheduler with a BPF program. Essentially, that's it. And of course, you can unload these BPF programs at runtime without rebooting your system. Current development is done Tejun is the main maintainer. The current patches are going there. We also have an SCX repository that hosts all the schedulers and tooling and user space stuff. So yeah, the SCX repository is really active, actually. We have many patches and contributions. Also have a Discord server. If you want to join, that's the link. But yeah, so this is just one thing that I want to highlight in case not everyone is really familiar with SCADX. We don't have the concept of run queues, but we actually map run queues using this local DSQs. DSQ stands for dispatch queue. There's one per CPU, and in SCADX, if you want to run a task on a CPU, you essentially insert the task into the corresponding local DSQ. And there's also a global one, which is up here, which is a single queue. It's still a FIFO queue, like I didn't mention, but these are essentially FIFO queues, same as this one. The global DSQ is consumed by any CPU. So the first CPU available, first of all, it checks if there's any task in the local DSQ. If there's no task, it will start peeking tasks from the global DSQ. Those DSQs are managed internally in the SCADX core. So you just need to insert tasks there, and then they're consumed automatically. In addition to that, user can create any amount of arbitrary DSQs. These are user DSQs that can be either FIFO or priority. Priority base means that like the different entries that you add, different tasks that you add are just sorted by an arbitrary number, a U64, which is called vtime, but it can be a deadline, vruntime, priority, whatever you want. And once you insert the task here, it's up to the user or whoever programs the BPF scheduler to decide how and when to consume them. So that's essentially the basic concept of SCADX, like how the queuing is working. And this part is pretty straightforward. There's not much complexity. I wanted to repeat this one. I've said this in other presentations, but just to, if I say DSQ throughout the presentation, you know what I mean. Instead, this is a little bit more complicated. So that's the entire task life cycle in SCADX, because SCADX, it's this thing, plus there are callbacks. And in order to implement a BPF scheduler, you need to implement some callbacks. You can implement all of them, part of them, or even nothing. If you don't implement anything, you can still load an empty BPF scheduler, and essentially these DSQs will be used, and everything is also working. You just don't have control of the tasks. Like it's just, you use the core scheduler, the core SCADX scheduler. Disclaimer before Chris, this doesn't represent like all the possible cases. We are trying to work on this thing. It's just pseudocode. Because I'm saying Chris because there was a recent discussion in the list, like This is not 100% accurate. We're still missing a few special cases, but I mean, it's, let's say, 95%, it represents what you can do in SCADX. So if you implement some of these callbacks, yeah, that's like how you implement your own scheduler. These two things, the ops TQ, are involved. That means, so it's a new thing. DQ used to be broken, and like even in V70 it's still broken. We have a fix for V71. So now you can, in 7.1, you will be able to implement a DQ callback that will be invoked when a task leaves the BPF scheduler. And it leaves the BPF scheduler means that you either dispatch the task to a CPU, so you insert the task in one of these or these. And that's easy because you have control when you say, you know, dispatch on this CPU. But there's another case or other cases where the task can leave the BPF scheduler, and it's when you change a SCAD property. So if you trigger the SCAD change, for example, you change affinity, or you change the nice, or anything that the core scheduler decides to do to change a task property, it would just remove the task from the BPF scheduler, and you don't directly see that unless you implement the DQ callback. And with the DQ callback, you can do a proper task state tracking. Let's say, so if you want to implement accurate pelt, you need that. Or if you have like queues or data structures that are implemented like fully in BPF, and you want to be able to determine when a task is not anymore in the scheduler, then you need to implement the queue to determine, okay, this task is being ripped off the scheduler, so I need to update my internal data structure. For instance, we have, for example, ATQs that are slightly different than DSQs. The ATQs are implemented fully in BPF using BPF arenas. So in this case, like if you want to keep track when a task is leaving the BPF scheduler, then in DQ, you need to do something that removes the task from your data structure. So that's a new thing. You can now rely on that. Yeah, I don't want to go in details in this huge thing. So anyway, just so you know that it's in documentation, scheduling, SCADX, if you want to take a look. So how SCADX is implemented? SCADX is a new SCAD class that runs below FAIR. So essentially, if you have like real-time tasks or FAIR tasks, they can completely starve EXT. That was before V70. Now we have the deadline server for SCADX. Similarly to FAIR, you know, I think you're all familiar with the old RT throttling issue that was essentially addressed or solved by the FAIR deadline server. Now we have one deadline server also for SCADX. So if you have like a CPU with a FAIR task running and an EXT task running all at the same time, the EXT task will still get a minimum amount of CPU bandwidth, which is 5% by default. And you may wonder, like, how is it possible to have FAIR and EXT running at the same time if by default, when you load the scheduler, all the tasks are moved into EXT. So in theory, you don't have any FAIR task. But the thing is, like, we have such thing called partial mode. So in partial mode, when you load a BPF scheduler, the core doesn't automatically migrate all the tasks from FAIR into the EXT.
Are you actually using that?
So we added this because someone from Google requested this. I think it was Joel, actually. now John Joy is in NVIDIA.
It works for you now.
Yeah, exactly. I think it was Joy, but someone from Google requested that, and we had other users requesting, oh, but I want to use FAIR together with EXT because they wanted to essentially EAS. They wanted the energy aware features, but still be able to use EXT. So the idea was having certain tasks running in FAIR and only a few of them in EXT, with all the complexity that
like partition to different.
Yeah, that's what we suggest. So before we had the deadline server, what we say was like, yes, you can do that, but you need to statically partition your system and separate the CPUs. Like you either create 2C groups, so let's say, with different CPU sets or whatever you want. You just partition your system. And that was the only way, literally, to use this partial mode without incurring into risks of starvation, because otherwise, like, there was no way. Now it's more flexible, meaning that, you know, you can play with different bandwidth and whatnot, and you don't have to statically partition your system. So it's a way that people can use, yeah. So that the same is valid for real-time tasks as well, because you can have a real-time task that is using 100% of the CPU, and EXT would still be able to get at least 5% of the CPU. This one was actually even more critical than the partial mode, because there are many distros or systems that are kind of abusing RT. You know, some audio like Jack or some applications like that are running as real time. I think KDE Plasma is even running something that's real time. So if you load a BPF scheduler, what happens is, you know, on a CPU, if for any reason a real-time task is taking the CPU for a longer period of time, it would starve the EXT tasks. And inside SCADX, we have this watchdog that if a task is not dispatched, if a task it doesn't run on a CPU for a certain amount of time, it would trigger a timeout that would automatically kick out the scheduler. Just to make sure that, you know, if you do something stupid in BPF and you're starving something, you still have this mechanism that you're not completely installing your system if you have starvation or any problem that you may have there, not consuming a task. Your scheduler would be ejected at some point. And that was, it's a good thing, but it was perceived by users as a, you know, critical failure, like, haha, you crashed your scheduler because, and then they were actually running, you know, crazy real-time tasks for 100% on all CPUs. And that was causing like a lot of, false positive bug reports, because like, oh, there's a bug in this particular BPF scheduler, or there's a bug in SCADX. So now hopefully we can reduce a little bit this false positives. And yeah, so on this aspect, it's pretty much all done. What we are missing, and we were talking with Yuri also, yes, what we are missing is a way to, so right now independently, if you are running a SCADX scheduler or not, we are still reserving the bandwidth via the deadline server for both for FAIR and EXT. So they both get 5%, and the rest would be reserved to real time. What would be nice to do is to, you know, if you load a BPF scheduler, not in partial mode, there's no reason to keep the FAIR bandwidth reservation active, because essentially nothing will run there. So ideally we want to like automatically unregister the bandwidth. And that's something that I need to look at that and do that. And likewise, if you don't have an EXT, the SCADX scheduler running, there's no reason to have the reservation for the EXT deadline server. So we want to unregister the bandwidth reservation automatically. It's not a big problem, because like if there's no task using the reservation, the bandwidth would be still used by the other SCAD classes. So
depends if then there is some condition that you need to keep some of the SCADX tasks back to fair, like I think sometimes
yeah. So we have this condition where, like, when a SCADX scheduler is unregistered, everything is temporarily moved. But they're not still in fair, so they're still running in the EXT class, but it's called bypass mode, where everything essentially is moved into the core SCADX scheduler, which is a FIFO, and waiting to be transitioned back to fair. So essentially what we need to do is to unregister the bandwidth reservation at the end when everything is moved back into fair, I think. Or
I was just wondering what happens if let's say that you have everything right now next, so you register fair, then for some reason the user actually adds scheduling proper task up to, let's say, 90%, and then there is no bandwidth anymore for fair.
So you're saying if a user is running like a SCAD deadline, not even RT, like deadline.
It's a corner case that never happens in practice.
Yeah, I mean, if you, it depends how you shape your bandwidth. I think it's right. Like, what can we do in that case? Maybe I don't know. Maybe it's a corner case. It's acceptable to. So right now the main problem was with RT, literally, and partial. We solved it also partial with that. SCAD deadline, I don't know about that. we need to think about that. But yeah, that's one thing. No big issues. We just need to take a look and do this. Instead, one thing that I would like to hear your opinion here in the audience. So the way that we have to, like, the interface that we have to configure the bandwidth is via debugfs, which is not the best. So yeah, the idea was like, do you have any concern about moving this stuff into syskernel SCAD? Because the reason is that debugfs, like, not all the people have debugfs enabled. And the other thing is, like, secure boot, kernel lockdown, they don't allow like changing stuff in debugfs. I don't know, Peter, Yuri.
So I was hoping to first get the replacement for FIFO C-group stuff merged, and then look at what the various bandwidth controls end up looking like before committing to an official API.
Yeah, there's also that in the next slide, because the next, I mean, we have the runtime and period interface also in cgroup FS, right? Because and with SCADX it's even more tricky, because like those are, you know, with fair, there's the fair takes care of the bandwidth that you define in CPU.max. But if you load a BPF scheduler, that thing doesn't work anymore, of course, because it's replaced by SCADX. So it's up to the BPF schedulers to implement the semantic of what you put in CPU.max. And maybe that's not a problem. Like, it, you know, it's.
I mean, that's, I mean, so the shit show that is SCADX. You can basically violate everything.
Oh, yeah.
You get to keep the pieces. You can choose to not implement C groups.
Yeah.
And it'll do something. It'll completely ignore everything. So yeah, I don't.
No, I'm not saying. I'm saying that's not a problem, because it's up to the BPF code that decides to. I don't know, that what we need to define is just the interface, not the implementation behind that when you load a BPF scheduler.
The interfaces should disappear if the SCADX thing doesn't.
Yeah, but how do you? I mean, people still need to define like the the bandwidth, maybe. So how do you let them?
If SCADX is ignoring it anyway, why have the interface?
No, but I mean this thing.
So this thing, like I said, I want to look at what the FIFO C group stuff will look like before committing any of this to AVI.
Okay. Yeah, makes sense. I see.
Another current interface that we have this CAD RT runtime period microsecond. Kind of confusing right now because they used to be able to disable RT throttling, but currently it's only disabling admission control for scheduling while the servers are still active.
Yeah.
So that's also something that we need, I guess, to change somehow.
Yeah.
So I want to do this once.
Yeah.
Make sure it all works together.
Okay, yeah, that makes sense.
Andrea,
yes.
Do you have a use case in mind for it? Because to me, the DL server was always it's convenient, but if on the one hand, if it triggers regularly enough, like frequently enough that you need to reconfigure those parameters, there's probably something wrong. And also, I don't know if anyone is using deadline above the 95% admission control.
Yes, so you're saying like at runtime you don't want to constantly mess up with these values. You just maybe have a boot time option. Is this what you're saying?
But who wants to have these options? I'm just curious.
You mean setting a different bandwidth? I'll show you one case.
Yeah.
In the.
Oh
yeah. So yeah, partial mode. You guys know what partial mode is. Well, so yeah, to answer your question. So let's say we have the proper interface. We like this one, whatever. Everything is fixed, right? Well, not really. Because, okay, partial mode, if you accept this, if you accept that SCADX runs below fair, everything is fine. Some users have requested, like, how can EXT run before fair?
Exclude mode.
What?
Just enable the BPF only mode.
Yeah, but then they still want to use fair. They still want to use EBDF, EAS, and all the fancy things together with EXT. But
yes, fair doesn't make sense.
Yeah, no, I mean there's people that want to run SCADX above the real-time classes.
Oh yeah. But so exactly, we need to find when is the limit that where's the nonsense limit? Like,
well, I think
we're past it. So no, but to give an answer to that question, that's what I suggested. Like you want EXT to win over fair, just assign a bandwidth to EXT greater than fair pure real time. That works. Like, you say EXT gets 60%, the rest is taken by fair plus RT. You're strongly reducing the RT bandwidth, but in practice, EXT wins over fair.
I mean, if we're being honest, already partial mode with EXT strictly below fair doesn't really work in many places, right? Like health it all becomes very strange.
Yeah, but I mean that's what you asked for, right?
I mean this satisfies the requirement that somebody is asking, right? So is there a better way? I don't see a better way with what we have right now unless we do.
So why aren't they using SCADX and that's it? Why?
So the use case is like I want to use fair, and I'm happy with fair.
Yeah.
But I want like to have a special C group or a special controller with a few tasks that will be managed by EXT in a kind of real-time way. That's what Peter was saying. They want EXT to be above RT. This is somewhere in between. They want to treat EXT as RT instead of using RT. So instead of using FIFO or round robin, they want some fancy real-time.
Well, we have a fancy real-time class. It's called Deadline.
Sched deadline. Yeah, they want to implement Sched deadline in BPF.
Why? Yeah, why?
I mean that's what people are asking.
Would be
Just say no.
Say no.
No is a valid answer.
No.
Maybe a question would be that maybe the interface is not usable for them. Maybe the actual how.
Yes, the deadline part requires some information from user space. You need to define your period and runtime.
Again, if we get an answer on why, we can also try to see
if it's doable. Yeah, but I mean, we can solve this for a specific request, but then we solve that, and then there's another guy coming in and say, oh, but I want to do something slightly different.
People that want ponies.
Sorry, Peter?
There's always people that want ponies.
Oh, yeah. I know. I mean, I'm not.
No is a valid answer.
Yeah. I'm not suggesting to say yes to everyone, of course. It's just, I was trying to see with the thing.
Isn't that more or less what SCHEDX is?
It's an automatic yes.
Yeah, but by my point is, I was with the things that we have without introducing new stuff. Can we answer? I mean, is this a valid answer to make this person happy? Because that person was happy.
So we don't know their ask. Why are they asking for this? This seems to often get lost. Like, what is the actual problem you're trying to solve? And can we do this? You've chosen this solution, but is there a better one? That's the question that should have been asked and isn't.
Yeah.
Just for me, you're speaking about bandwidth or scheduling priority.
Patch submission 101.
Because I mean, you can always modify
What is the problem? Solve that.
DL server to have more bandwidth for SCHEDX. But
Yeah,
it's already doable. But we after fair.
Yeah, exactly. That's essentially what I suggested. You add you assign more bandwidth to extra than fair plus real time.
Okay, it's not running first then. I saw that you wanted the
I know
first.
Yes, that's another approach. But it's even if it runs laster, it doesn't run first. With this one, you're getting more CPU bandwidth. So even if it's second, it still somehow wins over fair, because fair would be throttled essentially. Yeah. So it works. Like
as long as fair, I would say, as long as fair has enough bandwidth to not starve everything.
But even if fair is trying to use 100% of the CPU, it would be still limited by the deadline part.
But
so
we already have some fair. In C group, we can throw some fair tests.
Yeah, C group is another.
It's already the case. So my main problem is that if you starve completely the fair or the RT or the DL.
But in C group, like, how do you, in C group, you can manage fair tasks with C groups, but EXT is out of the equation, because if you have EXT, if you load a BPF scheduler, the C group interface that manages CPU max is just ignored unless the BPF scheduler is actually implementing something. So that the only thing that we have is deadline, the Sched deadline, I think.
The only, like, for me, the sane way to be using partial mode production at all would be maybe like a CPU static partitioning. Some use fair, some use X. But to me, it's also unclear what the problem they're facing is, and if that would be a way to path to explore or not.
Yeah, I mean, I agree that the best use case is to do static partitioning. If you don't do that, I mean, you're not completely lost. At least there's a way to, you have a minimum bandwidth guarantee, and then it's up to you how you define the bandwidth, right?
I don't think it's partial mode. Yeah, I mean, fair expects to be the last. Yeah, I mean, with some footnotes maybe, but.
Yeah, but I mean, if
the assumption that fair is the last.
Yeah, but like it's something that people can use. If maybe it's not the best, but if it works, why not? Like,
also, this is something they can do right away.
Yeah, exactly. We don't need to add anything. I was just, The goal of this slide was to discuss that we have this, and people may use this thing in this way.
Yeah, I would still guess reiterate the fact that getting more information how they're using
why
would be
interesting. Yeah, we can collect this information, and yeah, sure. Okay, well, that was the. So the other thing, where's Yuri? Not Yuri, the other Yuri. Yeah, the other thing that was considered is, can we rely on the hierarchical deadline servers to do, I don't know, some RT, non-RT parent grouping, and assign different bandwidth, and within each macro group have other deadline servers. So essentially rely on the hierarchical deadline servers to do something better. I don't know. I would say no for now, because we already have, what we say here. Maybe that's fine. It's already border limits this thing. So why add more complexity? But and I don't know the status of the hierarchical deadline server, but once we have that, maybe, yeah.
I would say in principle it should be doable. I mean, it's a second level of schedules if you want to make it general. Not sure if you want to add that complexity if it's not.
Well, the thing is, like, so from a SCADEX perspective, it's zero complexity, because we would just reuse
but the implementation of the hierarchy.
Yeah, exactly. What we need is the hierarchical part of the deadline server. So that's one thing to keep in mind in the future if we want to exploit this as a potential use. So if we have the hierarchical deadline servers, SCADEX can be a potential user. That's my message, essentially. Yeah. Okay, let's move on. Yes, so the other thing, if things can get more spicy, because now we have C-group subschedulers. I mean, this is a slightly different topic, not related to the deadline server, but just so you know, it's something that we have some groundwork for this already in V7.1. I think Tejun already sent the merge request with this part included. So we have like an early prototype in SCADEX so that you can attach different BPF schedulers per C group. It's still like, again, like I was saying, it's still a prototype or some groundwork, meaning that, you still, it's up to the parent scheduler to trigger, to invoke actually ops dispatch of the children. Ops dispatch is the callback that is invoked when a CPU becomes available. It's a pre-balance, essentially. The thing is, like, so your BPF scheduler needs to implement a couple of callbacks. One is, when you attach a sub-C group. The other one is when you detach that. But the idea is to, from a semantical perspective, the idea is to allow people to reuse existing SCADEX schedulers without any modification or minimal modifications, and just attach their own scheduler to, you have a container that is more latency focused. You attach, I don't know, LAVD, for example. You have another container that is more CPU intensive, and then you run, I don't know, SCX Cosmos or any other scheduler. And then in a cloud or virtualized environment, you can have multiple BPF scheduler for each C group. Something that is happening. We're still working on that. It's not like 100% complete.
You say C group, is that CPU set, or is it actually nested scheduler?
It's nested schedulers, yes.
So if you nest the compute and a latency sensitive one, then somebody needs to resolve this, which is yet another scheduler on top that needs to know about both those constraints.
Exactly.
So it's turtles all the way down.
Yes, correct. It's so essentially in the top level scheduler, you have a scheduler of schedulers. a fair schedule. You need to schedule sched entities that can be either tasks or schedulers. The scheduler part is just invoking ops dispatch, which will invoke the ops dispatch of the subscheduler, the children, and do their own scheduling thingies. That's the design. I wasn't a big fan of this. I'm not trying to justify. No, because I understand the concept, and it can be useful. If you have a cloud environment and you wanted to do, I don't know, different scheduling policies per cgroup, makes sense. I don't know if like adding this complexity in the kernel was the best decision, because in theory you can do all of this in BPF. Like you can completely do this in BPF, but if you do this in BPF, all the schedulers require more changes because you need to model this whole machinery in the BPF part. If you do this in the kernel, it's kind of more convenient because the BPF schedulers require less changes.
Realistically, they already do require a lot of changes because
they do, yes.
You don't get first picks on the CPUs, and like it's already
the thing is so you have the leaf nodes don't require many changes because they're this whole thing is kind of transparent. You need changes in the middle nodes or the top nodes.
Changes they certainly do, in my opinion. At least, if not like the entire complexity suddenly isn't like the scheduler of schedulers, then maybe not. But yeah, I don't know.
Yeah, you still need. I have a prototype that works with this new feature. It's I had to implement a fair sched class that is scheduling schedulers. With that, it works, but it's kind of I don't know. It's something that people have been requested, and many people are enthusiastic about this. I'm not a big fan of this, but something that is happening. And yeah, there's still work in progress to do. So yeah, next thing is the last one. I was hoping John was here. He's not. John Stultz. Sorry?
He was hoping too.
Yeah, I was hoping too. Yeah, I'm sorry about that. So I started to look at this. Actually, John started to look at this, like how to integrate proxy execution with SCHEDX. Because right now they are mutually exclusive. You can't enable both at config time. And the reason is because SCHEDX is not, either proxy execution is not aware of SCHEDX or SCHEDX is not aware of proxy execution. There's no, in the SCHEDX core, we're not considering RQ donor, which is the whole mechanism of proxy execution. For those that are not familiar, proxy execution, when you have a task blocked on a mutex and another task wants to acquire the same mutex, semantically, the waiter is actually switching context to the lock owner, giving its own time slice, let's say its own budget to the lock owner. That's the idea. Why it's not working with SCHEDX? Because we just need to implement the whole mechanism of looking at the donor. So in SCHEDX is more complicated because like the main thing is like, is this breaking the certain BPF schedulers when you switch context? Like, we don't know because a BPF scheduler can do anything, right?
BPF promised no ABI, so it's fine to just break everything, right?
Exactly. No, that's a good point. That was actually what we decided at Plumbers. At Plumbers, we said, we don't have any ABI restrictions, so let's just do it. And
so there was some other things that Tejan scheduled for removal, and he had this many release cycle plan to drop it, and I was like, "Why you don't have ABI? Just rip it out."
Yeah, we try to find the best compromise of not breaking too much. And so we keep certain ABIs in the kernel for a couple of 2 or 3 releases, and then we drop them just to keep up with the distros that are shipping like old kernels or stuff like that. But yeah, we can break things. We try not to, and BPF is helping a little bit, because if you rename a function or you add more arguments or remove arguments, there are tricks that you can use at load time to make everything backward and forward compatible. But we definitely don't want to maintain all the different changes forever. At some point, we just drop them. And yeah, makes sense.
You can do forward and backward compatibility, but in practice, oftentimes like the verifier changes or your tool chain changes, and
yeah, I mean, you don't want to maintain all the different ABIs over time for forever, because it would be a mess. But yeah, so I started to so there was this patch by John. It's actually really small, honestly, and kind of work already. I just reapplied that, tried to compile a kernel both with SCADEX and proxy exec. Everything works except that I'm getting problems with migration disabled tasks. If I enable proxy exec, sometimes I have a migration disabled task that is consumed in the wrong CPU. So that creates errors in SCADEX. And I think the reason is that, that sometimes there's a race where proxy exec is like switching context, but the task like donor is still in a DS queue, in a dispatch queue in BPF. So the BPF part would try to consume the task from the DS queue, but at the same time, the task is running on another CPU, which normally would be ignored. But in the race, if the BPF part wins, you end up running the task in the wrong CPU, let's say, and then you get an error. The BPF scheduler is ejected. It's not a critical kernel error, but it's just.
Is it the same issue that I tried to fix the BPF locking for?
Which one was that? Is it the wait?
So I can't quite remember, but so I tried to fix the BPF locking, and then Tejan said, no, we need this user DSQ. They need to do their own.
No. I think that was
down and backwards. And
no, I think that was about. Now I remember what you're saying.
Because that would tighten up.
Or maybe it's related. I don't know. Because if I remember correctly, that was. Yeah, I don't remember. Maybe.
Yeah.
I need to look back at the whole thread. But yeah, that's something I'm looking right now. I was hoping to have a patch before the conference. I didn't have time, but I mean, it's a thing. We can figure this out, and I wish we can. I mean, the thing that I want to remove is this thing. Like I don't want them to be mutually exclusive, even if it's not perfect. But I want to remove this because distro then will be able to enable both. And, we always advertise SCADEX as a way to, if you have latency issues, just load LAVD, for example, or Changuer. And then we don't have proxy exec, which seems a little bit,
So with proxy exec, you can move the donor from outside the affinity mask to a CPU where the owner is.
Yeah, but you're not actually running.
Yeah,
you're just moving.
Correct. So, but then we hand it back to you saying that you have to pick this task and we'll run the owner on its behalf.
Mm-hmm.
So again, it becomes like SCX is dispatching a task outside the affinity mask to a CPU. And then in the core, we kind of.
No, but I mean, it doesn't. So proxy exec is just moving across run queues, right?
Yes.
But that's not a problem because, like in the BPF side, you are just consuming from DS queues. We're just ignoring run queues. So if a task is on a run queue and not on a DS queue, it's outside the visibility.
Okay, so you're saying when the deactivate and activate happens, it's put on the local DSQ and not given back to the.
Yeah, I think when there's a proxy exec is doing the proxy tag proxy exec tag, something like that is the queuing and enqueuing.
That is gone now. So.
Yeah, I've seen it. So maybe now it works. But with that, I think when that proxy tag was happening, I think the task was dequeued, but we didn't remove the task from the BPF side.
Okay.
So it was enqueued again. The task was still in the DS queue. Then we have the same task that is inside the ops enqueue in BPF. The task is added to another DS queue, which is fine normally, because like if you do stupid things in BPF, the core would try to,
Correct. So what?
do the.
No, when the code fixes it, I feel like you'll just get stuck in a loop where you put it on a CPU where it splits the affinity mask. You again get to realize that it's blocked on the lock. You try to move it back. Gets into the SCX core. It tries to the whole cycle.
And then that could be another that can happen, I think.
But now with your DQ callback, maybe at some point you can take back the control and give it back.
Yeah, exactly. So the fact that we have a working DQ now, I can reuse that machinery to fix this, and that's what I was working on, and so it's in progress. Maybe I'll have something. There's another thing too. We moved. This is also in B7.1. I thought Tejan was sending this later, but it included this one. It's essentially in callbacks. We have all these callbacks, but inside the callbacks you can invoke k-funcs that are kernel functions, but not. I mean, you can't invoke any arbitrary k-func from anywhere. There's a context, and we need to make sure, you need to verify that a k-func is allowed in certain callbacks. And right now we are doing this at runtime, which has a cost. Like there's a mask per task, a bit mask with, every bit the side that defines the context, and it determines if a k-func is executable or not from that context. Recently, we moved these checks at verifier time rather than at execution time, because the verifier, in theory, it knows how to verify the validity of a k-func based on the context. So that means we can reduce some overhead. I don't have the numbers. I have the numbers, meaning that at some point I did something really brutal. I just removed the check, like allowing k-funcs to be called from anywhere. And in like certain with AI workloads, I was doing the training and what was that? Yeah, it was essentially training of RegNet. I don't know if you're familiar with that. I don't even know what it's doing, but some AI workload. And I was getting like 2-3% consistent speed up. So that's just to say, as BPF improves and reduces the overhead, we also get some benefits from SCADEX and vice versa. If BPF introduces regression, we have regressions in SCADEX, of course.
You know how that works with the verifier thing with timers, for example. The verifier will pull in, if you start a timer, it will pull in the timer function into the function. Well, of course, it's not actually being run in that callback. So technically, your timer function has a different KF mask than the one the verifier will currently pull it into. Right?
Come again?
Well, the verifier, let's say you are in enable.
Yes.
And you start a timer.
Okay.
Verifier will use the function that is being run on Nix.
A timer, you mean a BPF timer?
Yeah.
With a BPF timer handler, right? Which is in a different context. Okay.
Yeah, but the verifier will pull that in and verify that function like all together with the KF mask of, in my case, enable. While of course that is unnecessarily restricting to, or maybe not restricting enough to the timer function. That's a different context.
So we have I think I verified that. We have SCX tickless, right? That is using a timer in this exact use case. In enable, it fires a timer and it uses some k-funcs inside the timer. I tried that and it seemed to behave properly, but I'm not 100% sure if it's a fixed or if it's still an open issue. I'll double check that, because yeah, it makes sense what they're saying, and I don't have an answer to tell you like why it was working. It was working, or maybe it wasn't, and I didn't notice. But I'll double check that. And last I said was the last thing. It wasn't the last thing. One thing that I wish we had, this is a request for Steven, who is typing. I want to be able to answer the question, why scheduler X is better than scheduler Y. This is like one of the most annoying questions that we receive, or actually, no, the most annoying one is, what is the best scheduler for me? I get triggered when someone asks this, because we don't have the tools. We don't have way.
That's my discussion on Wednesday.
Exactly. I'm passing the ball to Steven. Okay. And I did some experiments with tracking perf counters, toolings, benchmarks, whatever. But I feel like we have Perfetto, which is an amazing tool, but I feel like we're still missing. You know what I mean. Yes. Okay. So Steven will cover the continuation of this talk. Questions. Cool. Everyone happy?
No questions.
No question. Awesome. Yes, Ryan.
This is a bit loosely connected, but about the slide with moving the k-func masks, essentially from runtime to compile time, speeding up BPF code overhead. I just have a question about kind of BPF code efficiency in general. This comes a little bit back to the tooling thing of how much profiling insight do we have into the cycles consumed by our BPF code itself, and do we have any estimate of what our slowdown is based on the BPF JIT being a simple sort of fast JIT as opposed to a LLVM03, linear scan register allocator versus graph coloring, et cetera, et cetera. I don't know if there's any benchmark suite that's assessing that.
Yeah, so we have some really nice tools. One of them is BPF top that shows you, you can do BPF top and it shows you the BPF functions in a top-like style. So you can see like, where's the bottleneck? It's great, but sometimes, it doesn't show you the actual BPF overhead. It's more of, the BPF callback or the SCADX callback that where you're spending most of the time is, let's say, ops dispatch. Does it mean that BPF has the biggest overhead in BPF is in ops dispatch? Not really. It's your ops dispatch implementation that has the biggest overhead. And so it's difficult to give an answer like how much is the actual BPF cost, because like we don't really have a way to measure that. You can.
Curious if you're aware of a benchmark suite to run the same C code compiled through vanilla.
You're saying I compiled the same C code.
For that one variable compiler quality.
Yeah.
Alexei seemed interested in those results, and I'm starting to have those now, like the S6 simulator.
Yeah, that's interesting. And
the easiest way to test this would be to lift the BPF JIT to user space, right?
Which I guess you can kind of do with UML, but
yeah, I'm just taking the JIT out. It shouldn't be that hard.
Oh.
Yeah, and
good idea.
Yeah, cool. Other Tommaso?
I make this very silly question. So going back to the part where you were talking about the hierarchical
CBS.
Hierarchical SCADX schedulers.
Here.
So what we are going to have today with deadline servers, having a class, a site for a reservation for get normal, then having a reservation for SCADX.
So you mean this slide or this one?
No, it's not a specific slide, just the idea, the concept.
Okay.
Hierarchical subscheduler.
You're saying what is overlapping?
We're already going towards a hierarchical scheduling where we are having a sort of, at least the main kernel without SCADX, right? It's like having a scheduler, the kernel that is scheduling other schedulers, for example, CFS, so it's scheduling.
They are.
Yeah. No, just asking. I don't know I mean, I assume it's true. There are use cases calling for these hierarchical features in the SCADX world, but maybe if can't that feature, the hierarchical scheduling feature, just be picked up from the ground up in the main scheduler code base and just,
I just don't know how this will ever work. I just can't see it work. It's really simple.
You don't see it working.
No.
And I'd say the other way around is probably better. As in, if you actually do have like schedulers, then merge them all into one, and let the kernel be oblivious to the fact that the subschedule. It's an option. It seems.
So no, that's actually the plan. Like you don't need to implement anything in the kernel. It's up to the BPF schedulers to decide the semantic of the hierarchy.
The scheduler of schedulers needs to be aware of the various constraints of the subscheduler. So basically, it'll all be one big scheduler anyway.
Yeah. So, what you mean for the burden of priority inversion problems or other?
The latency constraints or what have you. I mean, if the scheduler of scheduler is not aware of latency constraints of one of the subschedulers, it will violate those constraints. So then your tiny specialized scheduler might be very good for that one workload because it knows that this packet needs to go there. But then the scheduler of scheduler is unaware and it doesn't give him the time when it needs the time, you're up a creek.
You know, it's going to be a best effort, best effort thing, because it's like
yourself, the analysis of whether it works or not, it's up to who configures the system. Like whenever you configure that in some ways, probably that you should know what you're doing and use the proper analysis, do the proper maths that allow you to
the whole SCADX thing doesn't have a schedulability model you can actually compute anything of. It's just do random stuff.
I guess,
yeah.
So
I guess.
Yeah, so it's also up to like you're saying, it's up to who's configured. Like if a sysadmin decides to attach random schedulers to the C group hierarchy, anything can happen. But you don't have. I mean, you may have starvation because maybe in a middle level node you have a scheduler that is like totally unfair and it doesn't give enough bandwidth to the children schedulers. You have starvation. Fine. That's it.
Yeah, so what I want to say, if you have time-sensitive workloads, you want to run it in the root. Of course,
if you have time-sensitive workloads, you're not using any of this.
Yeah, but even if you have a root priority scheduler and you are running a deadline scheduler or a time-sensitive scheduler, whatever it is, as a first priority, the first priority of that. It could be a hierarchical nested scheduler where you can still get probably timing guarantees for time-sensitive tasks, and then let anything else go. Anyway, I mean, you can configure as you like, probably, but yeah. Well, so
I thought we were already there with the SCADX. You can do whatever you like. Just now they want ponies.
Yeah. Anyway, I did my question. Thank you.
No, it was a valid one.
Yep. Okay.
Thank you.